Welcome to Mathematical Tools Part 2. In our last class, we have done with the topic of coordinate geometry and correlating that with vector and trigonometry. And as I told, this class will discuss mostly with trigonometry. So to start with trigonometry, that is the second topic. Trigonometry, question arises, why we need trigonometry? If you have geometry, if pyramid is being made with geometry, then why we need trigonometry? What is need of trigonometry? Suppose say there is a river like this, a huge river, and there is a palm tree on the bank of the river, and you want to, without crossing the river, you want to find the width of the river. So for that, we know this length, we can use some technique to find out the width of the river. This is in question mark, and we can find out, we know the length of this, height of this palm tree or supari tree, and we know the line of sight. Somebody goes up and find out line of sight. This is the angle, we know this now, and we know 90 degree. And then we can also find out this, because a triangle is made up of 180 degree. So 180 minus this will give this angle. So three angles are now known to us, and this length, one length is known to us. So we can find out this and this, whatever you want, in a right angle triangle, of course. In our previous class lecture, you found we talked about a coordinate system, where we talked about a point P, and it was somewhat like this. It is a right angle triangle again, where this is 90 degree, and this was my point P. That means if I make a line here, this is one right angle triangle, this is another right angle triangle. This is theta. If this is theta, this is some alpha, suppose say. This is 90 minus theta, and this is 90 minus alpha, because this is 90 now, this angle is 90, and this is again 90. So we have two right angle triangles, one is this, another is this. Let's concentrate to this right angle triangle. Now let's go to one mathematical theorem that says, if you have a circle like this, then small arc subtended to a circle, this is my arc S, suppose say, and this is my r, and this is theta. So we can say in this, S is equal to r theta. The proof is the work of mathematics teacher, not of physics teacher. So I'll just bring into reference S equal to r theta. Now suppose say I have a, now come to one more reality. If you have a big curve, take small part of the curve. A small part of the curve is nothing but a straight line. So when you take the angle theta to be very small, this S, the arc, is almost like a straight line. If it is a straight line, then either of this angle or this angle will be 90 degree. Both of them cannot be 90 degree, because then it will be together 180, and nothing is left for this theta. So we consider this to be, one of them to be 90 degree, and if so, then this is perpendicular, this is base, and this is hypotenuse, and this is nothing but a right angle triangle similar to this right angle triangle or this right angle triangle. If so, then in this right angle triangle, where this is my perpendicular, this is my hypotenuse, and this is my base, I can consider theta is equal to P by H. Like S is equal to r theta, so you can say here theta is equal to S by r. So in place of S you take P, in place of r you take H. Now we give particular name to this, and we call this a sine function. Sine theta is equal to P by H. This is physical meaning of sine component. We'll come to more details in physics, how we actually discuss sine and cos function, but right now I'm concentrating only sine function, and later you will come to understand the cos function. Right now we can go for this. Suppose say you consider change color of my pen and then show you. Suppose say you have this point as my 90, this is nothing but 90 minus theta. Is it clear? 90 minus theta, because this is in all 90, so this part is nothing but 90 minus theta. So if I consider 90 minus theta in this right angle triangle, this now becomes 90 degree. So which is this is hypotenuse, this remaining hypotenuse, this I'm redoing by blue. This is my hypotenuse, this is my base, and this is my perpendicular. Now because things have changed, the angle that is opposite to the theta, the concerned angle, is perpendicular. So this proves to be perpendicular now, and this proves to be base, and this is my hypotenuse. So in this triangle I can say sine theta is now 90 minus, what is my value? It is 90 minus theta. Theta is 90 minus theta is equal to, now this is my arc, this B is my arc, this is my center, so I can say 90 minus theta, S is B, S is equivalent to B now here, and I will write B here, and R is same, that is my H, so I'll consider this to H. So this is a new format. You come up with a new format, we call it sine 90 minus theta is equal to B by H. Instead of calling this every time as sine 90 minus theta, we can claim this to be a new name, cosine. So in short we call it cos theta, we'll call it cosine theta. Means wherever you mention cos, you mean to say actually 90 plus or minus. Here I give example of minus, there can be same as that of 90 plus theta. You can try that yourself, it's all the same. So this is equal to B by H. In normal trigonometry in junior classes you have done, some people have curly brown here, so this is your base by hypotenuse. So you get two trigonometrical functions, sine and cos, with your basic mathematical fundamentals, and utility is known to us that we can find out this width of a river. So if a king wants to cross the river with a ready-made bridge without crossing the river, then he can easily calculate out the width, and this is how perhaps trigonometry started. This is how we start with the concept of trigonometry. In physics, we won't go to much details of trigonometry. The reason is very simple. We need to only have implementations of trigonometry in our work. Like for example, if we talk about the trigonometrical functions, if I clearly mention only the trigonometrical functions, you all know in junior classes you have done 0 degree, this is 0 degree, 30 degree, 45 degree, and after that you have 60 degree and 90 degree. There's tremendous meaning for this. So I find out the sine value of this, then I also can find out cos value of this, and I also can find out tan value of this. Still now tan I didn't explain, I'll go to explanation of tan and then we'll come to this. So sine 0 is 0, sine 0 is 0, sine 30 is 1. We have a method to find out this. In junior classes you have done. What do? We take 0, 1, 2, 3 and 4, and we divide this by 4, and we divide all by 4 separately, and this you should remember in junior classes you have done. This is, the values are very important for you, and square root. Then we go for square root, we go for square root, we go for square root of this, all the values, and this is also square root, this is also square root, and square root, and square root. Now the value, first value, 0 divided something is 0, so give value to sine, and this is half, and this is 2 by root 1 by root 2 we get when we divide this, and this is root 3 by 2 by giving this value, and this is 1. 4 by 4 is 1, and square root of 1 is 1. So we take this cos value, sine value here, so this becomes 1, and this comes here, this comes remains here, this remains 1 root 2, this becomes half, and this becomes 0. This I am telling technically how we do it. In tan theta, we just divide this by this, means this by this. So 0 by 1 is 0, and this is this, and this becomes 1 by 0. So something divided by 0 is infinity. You all know this. I consider that you are all aware of this technique and the standard values. My concern here is to explaining what is the actual meaning of these values. This value 0 means it says sine 0 gives you 0. The actual meaning, if you go to the actual meaning, we can see here sine 0 gives 0. That means the perpendicular should be 0. So theta turns to be 0, and this value turns to 0, means this line coincides with this. Obviously meaning is 0. Whereas in case of cos 0, this becomes this is cos 0, b by h. B becomes maximum. Mathematically, if we go, b becomes equal to h, and in that case you get cos 0 equal to 1. There are two meanings. In physics we are not that much concerned of the mathematical symbols till we don't understand physical interpretation of this. In all mathematical terms we have to be very clear about the physical meaning of this. Another point is this: suppose say you talk about this value, this is 0 degree, gives you decimal value 0, and this 30 degree is 0.5. That means 15 degree, mathematicians won't accept this. In physics we approximately assume this to be this. So 15 degree is supposed to be approximately 0.25, approximately. This is for quick calculation, you use this, otherwise we normally need sine table to find out actual value of sine 15 degree. Similarly, all the values that means you are making the values of degrees in the decimal line. That means these values are nothing but you are plotting them in a number line starting from 0 to 0.1. That means something here, something here, something here. This is where 1, suppose say. So from 0 to 1, this is 0.1, 0.2, 0.3, 0.4, and so on and so forth. That means you are finding out the decimal value of the angular value, what you call as radians value. Similarly for costs also we do find out. But to explain further how actually tan function evolved, I have to tell you a little more story. That we have a coordinate system like this. I'll draw it there to make it more clear. I have a coordinate system like this.